When we think of a worker's decision of how much to work, we're implicitly also thinking of the worker's decision of how much to consume, because how much the worker works will determine how much income he has in order to consume. We will therefore often model the choice that a worker faces as a choice between leisure and consumption. Leisure is what he owns. He can sell it in the labor market by working and earning income that he can then spend on consumption. On the graph with hours of leisure on the horizontal and dollars worth of consumption on the vertical, we begin by illustrating the worker's endowment bundle, assuming that the worker has no saved assets. In this case, all the worker has is the hours of leisure that he can sell in the marketplace. His endowment is therefore a bundle on the horizontal axis. In particular, we could assume that the weekly endowment the worker has of leisure he can sell in the labor market is 60 hours. Bundle E is then his endowment bundle. If this worker's wage is $20 an hour, then if he sells all 60 hours of his weekly leisure time, he'll be able to earn $1,200, which means the most that he can consume in dollars worth of consumption this week is $1,200. His intercept of the budget on the vertical axis is therefore $1,200, indicated by bundle B. Connecting the vertical and horizontal intercepts that we've just determined, we then get his weekly budget constraint between leisure and consumption. The slope of this budget constraint is minus 1,200 divided by 60, or minus 20. In other words, the slope is the negative wage. This makes intuitive sense in the following way. For every 1 hour of leisure that this worker consumes, he's giving up $20 worth of consumption because he's not getting paid the $20 for that hour that he could have made. The opportunity cost of the good on the horizontal axis, leisure, is therefore the wage that is given up by consuming that leisure. The worker is likely to end up on neither of the extremes in his budget constraint. He's probably not going to consume 60 hours of leisure and consume nothing in terms of goods, nor is he likely to consume $1,200 worth of goods and no leisure at all. He might, for instance, choose to work for 40 hours, which would leave him with 20 hours of leisure. Note that the horizontal axis measures hours of leisure, not hours of work. So if we want to see in this graph how much he works, we have to take the difference between his leisure consumption, which we just said might be 20, and his leisure endowment, which is 60. Thus, a worker who consumes 20 hours of leisure when he has an endowment of 60 hours of leisure is working for 40 hours. When working for 40 hours a week, this worker therefore ends up at bundle C on his budget constraint. At a wage of $20 an hour, he earns $800 in income, which then becomes available for other goods consumption. Bundle C therefore contains 20 hours of leisure and $800 worth of other consumption per week. Next, suppose this worker's wage falls from $20 an hour to $10 an hour. His leisure endowment hasn't changed. He still has 60 hours a week that he can sell in the labor market. Thus bundle E is unaffected. But even if he sells those 60 hours at a wage of $10 an hour, the most in other goods consumption that he'll be able to consume is $600, not the $1,200 he could have consumed when his wage was $20 an hour. Thus the vertical intercept of his budget constraint shifts down from 1,200 to 600, from bundle B to bundle B prime. This implies that the decrease in the wage will rotate the worker's budget constraint from the original blue budget to the new magenta budget, keeping in common only the bundle E, the endowment bundle, of 60 hours of leisure that the worker can always consume no matter what the wage is. The slope of the magenta budget constraint is now minus 600 divided by 60, or minus 10. In other words, minus the new wage per hour. This again makes sense. the opportunity cost of an hour of leisure has now fallen from the initial $20 an hour to the $10 an hour that we are now giving up when we choose to leisure rather than spend the hour working. Notice that if you didn't know what the goods were on the two axes, if you just thought the good on the horizontal axis was x1 and the good on the vertical axis was x2, you would look at the blue and magenta budget constraints and conclude that from the blue to the magenta budget constraint, the price of good 2 has increased. Here, however, it is the wage that has decreased. But we're also not dealing with an exogenous income as we did in Chapter 2. Rather, we're dealing with an endogenous income, an income that arises from the worker selling something that he owns. A decrease in the wage then looks a lot like an increase in the price of consumption, and if you think about it, that's exactly what it is. If I consume $1 more when my wage is $20 an hour, I'm implicitly giving up 1/20th of an hour in order to earn that dollar that can get me that additional consumption. But if my wage falls to $10 an hour, I'm giving up 1/10th of an hour, twice as much, when I consume $1 more of consumption. Thus, as my wage falls, the price I pay, the opportunity cost of consuming, has increased.